Hello everybody, this is Mrs. Wild from your WCA physics class. And I'm just going to quickly go through what you need to do for the specific heat capacity portfolio. I do want you to see here that this thermal energy transfer portfolio, that I have the replacement for that, which is a specific heat capacity portfolio. So you're going to click on that and it's going to open here in Google Docs. Now, I shouldn't have to tell you guys this, but I will. You can either download it to Word or, let's see here, Microsoft Word, or you can make a copy. And for now, I'm just going to make a copy of it so that we can edit the copy without destroying the original. And I'm going to go ahead and click on this link. It's going to bring me to this simulation on FET, Energy Forms and Changes. And according to this, we are going to basically just do some kind of simulations to see if we can answer the questions here. So it says, is it possible to boil water? Well, let's go to, let's first open this up. And we are going to go here into the intro. And so what we're going to be doing is just playing with this kind of equipment that's on here. So we want to be able to boil the water. You're going to play with this. You can always add a thermometer to this if you need to measure temperature. So that's something you can do. You can change the heat on the bucket. You can either heat it up or you can take heat away by moving it to cool. You can put energy symbols in so you can see how much energy is found in every location. So we can see there's a lot of the little energy cubes in the water. There's more in the iron than the brick, and it kind of gives you that. And if you want the heaters to function as a single unit, you can link them together. So we don't need to do that right now, but that's kind of the gist of how this works anyways. So you're going to see, is it possible to boil water? Is it possible to freeze the water? Make sure to attach the temperature gauge so you have a guide. Remember, you know what the boiling point and freezing point of water is. And then make sure you always answer all parts of the question because it does say what do you need to do to make these changes happen. Then it says chill the water as much as possible, then add heat and observe. List at least 3 things you noticed. Make sure the energy symbol box is checked. Add heat to the iron and heat to the brick at the same time. Which one can hold more energy? How and where do they lose their energy? Number 4, add a heated up bit of iron to room temperature water. Describe what happens in detail below. Number 5, place a brick on top of the iron and add heat. Describe what's happening in at least 3 sentences. And number 6, take the same setup from number 5 and instead of heating it, cool it down and describe what happens in at least 3 sentences. And once the brick and iron are cooled down, do they have the same thermal energy? Do they have the same temperature? Does the room temperature water have more or less energy? And then just answer these. According to what you've done so far, what material can hold the most heat? Which takes the longest to cool down? How does heat flow? How does it move? Think about that first law of thermodynamics and what evidence do you have to justify the answer, okay? So you're just making observations and answering questions for this and then saving this document and submitting it to me in the Dropbox. All right. Hope that makes sense, everybody. Thank you so much and have a great rest of your day.